So when we talk about AI, we're always obsessed with making them smarter, right? More accurate, more capable. But what if I told you there's another, secret war being fought in the background? A battle not for intelligence, but for pure, raw speed. This is about the AI speed wars.
Because, let's be real, you can spend months building the most brilliant AI model the world has ever seen. But if it can't give you an answer right now, what's the point? If it's too slow, its value just plummets. That's the performance bottleneck, and it's a huge problem.
So, this critical moment where an AI model actually has to do its job has a name. It's called inference. You can think of it as the moment your AI graduates and has to go out into the real world. And, well, it turns out that first day on the job is incredibly demanding.
Yeah, during inference, everything can get stuck in a massive traffic jam. We're talking about things like memory bandwidth, how fast data can move around, and just the raw compute power of the hardware. If any piece of that is slow, your brilliant model gets stuck. It might be a genius, but it's a genius stuck in traffic. And that's the problem we need to solve.
Okay, so to solve this gnarly speed problem, a few major players have stepped into the ring, each with a totally different way of fighting. We're going to break down 3 of the biggest contenders in this high-stakes race. First up, we've got PyTorch. Now, you should think of this as the workshop. It's the popular, super flexible place where most AI models are actually born. It's the go-to for researchers and developers everywhere.
PyTorch is amazing for building and experimenting because it's just so easy to use. It runs in what's called eager mode, which basically means it does exactly what you tell it to, one step at a time. That's fantastic for debugging, but that same step-by-step process means it's not built for pure flat-out speed. It's the starting line, you know, not the finish line.
All right, next in the ring is OnNX Runtime. If PyTorch is the creative workshop, OnNX Runtime is like the universal translator from science fiction. Its superpower is making one thing work everywhere.
The real magic behind OnNX Runtime is this cool concept called execution providers. You can think of them as special adapters. It lets you take one AI model and then run it efficiently on a whole bunch of different hardware. NVIDIA, your laptop CPU, a Mac, you name it. Its main goal isn't to be the fastest. It's to be fast everywhere.
And that brings us to our final contender, NVIDIA's TensorRT. So if OnNX is the versatile translator, TensorRT is the hyper-specialized, completely obsessed Formula One race engineer. It cares about one thing and one thing only, winning the race.
Yeah, TensorRT just throws versatility right out the window. It is built for one job, to squeeze every single drop of performance out of an NVIDIA GPU. It does these insane, super aggressive optimizations that are only possible because it knows the hardware inside and out. It's not about running everywhere, it's about being the undisputed speed king on its home turf.
So there you have it, the Creator's Toolkit, the Universal Translator, and the F1 Engineer. But, you know, talk is cheap. Let's see what happens when the rubber meets the road. Let's look at the hard data.
Whoa. Okay, let's break this down. Take a look at the top chart here. The blue bars, that's your standard out-of-the-box PyTorch. The orange bars, that's the same model after TensorRT has worked its magic. I mean, it's not even a fair fight, is it? Across every single model size, TensorRT is just worlds faster.
I mean, just zero in on that middle model, the N version. PyTorch is doing great. 137 frames per second is nothing to sneeze at. But then, bam! TensorRT takes that and launches it into the stratosphere, over 233 frames per second. That is just a colossal leap in performance.
But here's the question you should be asking, right? What's the catch? All that speed must come at a cost. You've got to be losing accuracy. Well, look at the bottom chart. Blue is PyTorch, orange is TensorRT. They are practically identical. This is the killer move. TensorRT gives you that insane speed boost with virtually zero drop in quality. It's incredible.
So we've seen that TensorRT wins big on speed. But how? How on earth does it pull that off? And why is its approach so different from something like ONXS? Well, it all comes down to their completely different game plans.
TensorRT has a whole bag of tricks. It does something called layer fusion. Think of it like this. Instead of making 5 short trips to the store, you make one big trip. It saves a ton of time. It also does precision calibration, which is a clever way of simplifying the math without losing any important details. And finally, it auto-tunes everything to run perfectly on the specific GPU it's on.
It's a level of deep tuning that a general tool just can't match.
And this diagram shows you the typical journey. You start with your model in that comfy PyTorch workshop. Then you often convert it to the universal ONX format. And then you feed that into the TensorRT optimization engine. What comes out the other side is this highly specialized, supercharged engine ready to go.
So here's the key takeaway. ONX Runtime and TensorRT aren't really direct competitors. They're playing completely different sports. ONX's game is portability, one model to rule them all, running everywhere. TensorRT's game is performance, becoming the undisputed speed champion on its home turf, NVIDIA hardware.
So, with all that in mind, how do you actually pick one for your project? How do you choose your champion?
Well, the choice actually becomes pretty simple when you look at it this way. If you're deploying on a big server farm full of NVIDIA cards and every millisecond counts, it's a no-brainer. TensorRT is your champion. But if you need that model to run on your customers' laptops, on edge devices, on a mix of hardware, ONX Runtime and its portability is the clear winner.
At the end of the day, it really boils down to this. Don't just pick the tool that has the most buzz online. Look at what you actually need to do. Are you optimizing for raw power on one platform or for flexibility across many? Your answer to that question tells you exactly which champion to back. And this leaves us with a really interesting question for the future. As these AI models get bigger, crazier, and hungrier for power, are we all going to need these F1 engineers like TensorRT just to keep up? Or, as AI starts running on everything from our phones to our cars, will that run anywhere philosophy of ONX Runtime be the thing that ultimately wins the war? The race is definitely far from over.